Hello, this is the second part of lesson 5-6b, solving exponential and logarithmic equations. So the first part, we solved exponential functions, and in this lesson, we're going to solve logarithmic equations. So let's go ahead and start with the first of three techniques. We're going to graph using Desmos, and then we're going to find the intersection point. So let's take a second and look at this first example here. All you have to do is graph the left side and then graph the right hand side. But you got to remember, when you graph the left and the right hand side, make sure that they are equal to y. That way Desmos picks it up as an equation. And I'm going to show you exactly what I'm talking about right here. So I've got log base 4 of x. As you can see, it does pick it up. It will graph it because it's got a variable in there. So it doesn't really hurt if you put y equals 2 in there. But if you're trying to do the right-hand side of the equation, if you type 1, it doesn't recognize it as a function. So you have to go in and you have to say y equals. So what we're going to do is we're going to go back to the notes. We're going to sketch this, but I'm also going to include the intersection point of the two graphs. Okay, so the logarithm looks like this, and the constant looks like this. And then let me just flip back here real quick. The intersection point was 4, 1. And very similar to what we did yesterday and some of the other lessons, if you're trying to solve an equation, it is going to be the x value of the intersection point. Okay, so here's what I want you to do. I want you to pause the video. I want you to go ahead and graph these other two equations, and I want you to find the solution by using the intersection point. All right, so here's the results that I got after graphing each equation. So over here on the left-hand side, this is what I wound up for my intersection point, which means that x is equal to 0.368. And then over here on the right-hand side, I wound up with an intersection point here, and my solution is going to be 2.236. And in case you want to see what they look like on Desmos, this is what the one on the right looks like. And this is what the one in the middle looks like. And there's your intersection point. So this is the technique that you're going to use if you have Desmos available. If you do not have Desmos available, there are a couple of options that you could use. You could use something very similar to what you learned about base equal base. If you have the same logarithm on either side of the equation, it's the same basic concept to where you can just drop the logarithm and you can say that the x and the y are going to be equal to each other. So instead of the exponents being equal, it's like the of the logarithmic function is going to be equal to each other. One thing that you do have to worry about, though, is that you can have extraneous solutions when you're solving a logarithmic equation. The reason why is because your domain is limited. So if your domain is limited, just make sure that you plug your answer back in to make sure that it works. Okay, so here's a couple of examples that use this property. You've got log base 2, see how they're isolated. That's the only thing that's on the left and right hand side. If you see that pattern, that means that x is going to be equal to 7. So that is as basic as it gets. Right here underneath it, I have a natural log. The natural logs have the same base e. And then you can simply just say that 2 plus x is equal to 9. Then you're going to have to solve for x. So helpful hints, make sure that the logarithm is on both sides of the equation. They are the same. You cannot have anything like, let's say you've got log base 8 of x and you have log base 8 of 10. That is good. That means x equals 10. But if you have anything else, like if you have like 3 times logarithm, you can't use that property anymore. If you have anything here like plus 4 on the end of it, that doesn't work. So it has to be just that logarithm, same base, and then you can say x is equal to 10, and then that will work. You can also do something called exponentiate. I don't think you're going to have to do that in Algebra 2, but if you know that one thing is equal to the other, you can raise them to a power using the same base. So let's say if you know that x is equal to 5, you can raise it to the power. You can just say that Let me rewrite that. X equals 5. You can say a to the power of x is equal to a to the power of 5. Just for fun. Okay, so let's look at a worked out example. So this is worked out. You notice that you have the natural log on both sides. If you know that they are the same on both sides, you can just drop the natural log and say that 4x minus 7 equals x plus 5. So we drop the natural log in this one, and we just have this part left over. So let's just write in what we did. We subtracted x from both sides. And then it looks like we added 7. Kind of skipped a step here. So we have 3x is equal to 12. And then we have to divide by 3. And then you wind up with x equals 4. Do we have to check our answer? Absolutely. So what you want to do is you want to just do a little spot check. 4 times 4 minus 7. So that used to be 4x minus 7. And this is the natural log of 4 plus 5. And that used to be x plus 5. So you have to take your answer and you plug it in for x here and here. And just make sure that these natural logs are equal to each other. So 16 minus 7, that's going to be 9. And over here, natural log of 9. Also, you're going to want to make sure that you're taking the natural log of a positive number. You're not allowed to take the natural log of anything that is not positive. So if it is even the natural log of 0, it will not work. And if you forget that, you can just type it in your calculator and make sure that your calculator will do it for you. But these do work out, and your final answer is 4. Okay, on to the next example. You have a natural log on the left, a natural log on the right, so everything checks out. I can drop the natural log. I have 5x plus 2 equals x plus 10, and then just simply get x by itself. Subtract 2 from both sides, and then divide by 4. Okay, so all you got to do is plug the 2 back in here. I'm just going to do this very quickly. Oop, that should be a 2. And then 2 plus 10. Are these going to be equal to each other? So 5 times 2 is 10 plus 2 is 12. And 2 plus 10 is 12. And they're both positive, so that checks out. Okay, well, if I can get this to not bounce around, we'll be good. Okay, so if you look on the left-hand side, I have log base 7. And I have log base 7. So everything else that's part of the logarithm is going to wind up being equal to each other. So I'm going to write x squared plus 5x equals 6. Now this is different from the previous two because this is a quadratic function. It is quadratic because it is x squared. If it is quadratic, you need to get it equal to 0. So I'm going to subtract 6 from both sides. And I'm going to factor. So if it's a trinomial, you're going to try to find the factors of -6 that add up to be positive 5. So I think 6 and 1 is going to work. I'm going to have to use a positive 6 and a negative 1. Okay, so factors aren't solutions. So if you want to find the zeros, you have to set each factor equal to 0. So I'm going to subtract 6 here, and I'm going to add 1 here. So this one has 2 different answers, and it's kind of it's neat. If you actually use Desmos to solve this, you have 2 different intersection points. So if you plug in the -6, if you plug in the positive 1, they both work. So this one has 2 solutions. Okay, so here's what we're going to do. You're going to pause the video, and I want you to work these 2 problems out and unpause it and see if you get the right answers. Okay, so if you look at this first one right here, you don't have to really change anything. Why does that keep marking that out? So you've got the same natural log on both sides, so go ahead and drop the natural log, and this is what you're left over. And then just go ahead and solve for x. So subtract 2x from both sides, add 4, and then divide by 5. And if you take that 3 and plug it back into the original, it does check out. So over here, you have the same common log on the left and the right-hand side with base 10. you're allowed to drop the logarithm, and you're left with 2x minus 1 equals 13. So simply just add 1 to both sides, divide by 2, and you wind up with 7. So in the last technique, we are not going to be having 2 bases, we are going to have 1. And this is very similar to what you learned in the first part of lesson 5-6 with exponential functions. If you have the same base on either side, then you can drop the base. But if you have 1 base, you're going to have to rearrange it. So same thing with 1 logarithm, you have to isolate the logarithm. So the first thing we have to do here is just make sure that there's nothing added to the logarithm, divided, subtract, anything like that. So I have a logarithm of base 2. I don't have anything in front or divided, so I can go ahead and go on to step 2. Same thing over here. See this logarithm right here? I don't have anything multiplied to it or divided to it. Same thing here. And same thing here. So these are actually very basic compared to what we had yesterday. So if everything is already isolated, you're going to go ahead and you're going to rewrite this in exponential form. So if you don't remember how to rewrite it in exponential form, let me show you how to do that. So you look at the base, and this base is x. You are going to write x to the power of a equal y. So x to the power of a is equal to y. And we're going to do that right here. So we have base 2 right here to the power of 3. That will be equal to 5x minus 17. So it's just a lot more complicated than what you did on the Kahoot that you played a couple of weeks ago because you just have more stuff, okay? So once you change it to that form, you want to get x by itself. So 2 to the 3rd power is 8. Then you can work on getting this isolated. So I have 25 equals 5x. Finish it out by dividing by 5. One more time, just make sure that when you plug in the 5 up here, 5 times 5 is 25 minus 17. That is positive, so that does work out. It is not extraneous. Okay, over here. Now listen, if you've got a common log or if you have a natural log, you're going to need to write in this base. So you have a base e that you don't see. So you're going to start writing it as an exponential function. So you're going to do e to the power of 3 equals 2x. Divide by 2. X is equal to e to the power of 3 over 2. That is the exact answer. This is perfectly fine. And if it's multiple choice and it wants you to figure out a decimal, then you just type in e to the power of 3 divided by 2. But that's basically how you do it. Okay, I've done a couple of examples here. I'm going to let you do the last one on your own, but let's do this one just in case. So I have base 2. So I'm going to do 2 to the power of 4. That's going to be equal to x squared. So this is a quadratic function. You don't have to factor this one because you don't have a linear term. So you can go ahead and just take the square root of both sides. You are supposed to have a positive and negative when you do this, but you're going to kick out the negative because when you plug the negative back in here, actually no. So you're gonna actually wind up with 2 different answers. So you have x equals positive 4 and x equals negative 4. Because when you plug in a negative 4, it's squared. So negative 4 squared is a positive number. So it checks. And if you really want to see something neat, you can type it into Desmos, even though that's not what we did in this lesson. So you got that one. And then if you just do y equals 4, it's kind of got this like look to it. It's kind of cool. So that would be your negative 4, and then that would be your positive 4. Okay, at this point, I want you to go ahead and pause the video, and I want you to see if you can work this last one out. All right, so you're going to write base 4, power of 0, equals to x plus 2. Anything to the power of 0 is equal to 1. And then I've got to subtract 2 to get x by itself. Am I safe if I plug this back in? Negative 1 plus 2? Yes, that's going to be positive, and that works out. So that's all I've got for you in this lesson. So just let me know if you have any questions.